All right, in this last section on stats for us, in chapter 15, we're going to talk about interpolation and extrapolation. So hopefully we see the prefix relation here between interpolation and extrapolation. Inter is within something, extra is outside of something. So what we mean by interpolation and extrapolation is simply making predictions about data values using regression models. And interpolation is the process of finding a function value that's between our given or known values. That is to say, in this particular example, say we see x values between 7.5 and 9. Or excuse me, 5.3 is our lowest, between 4.7, I'll get there, 4.7 and 9. So if we pick an x value that's between those two, then we're doing interpolation. We'll see in the next problem that if we pick values outside of those known values, we're doing extrapolation. So interpolation, again, is making predictions within the known data values, and that's a nice, sound statistical practice that we do a lot. So let's go ahead and get right to an example. Here it says, each time Jen fills the tank of her car, she records the number of gallons of gas needed to fill the tank and the number of miles driven since the last time she filled the tank. Her record is shown below. So she filled the tank with 7.5 gallons and she drove 240 miles on it. She filled it with 8.8 and drove 280 miles, etc. Okay, or really more likely it would be she drove 248 from a full tank and then needed to put in 7.5. Same idea. If Jen needs 8 gallons, the next time she fills the tank to the nearest mile, how many miles will she have driven? And you can ignore this. Usually in class, I'll share a document on the calculators with you so you can save some time entering data in, but for now we won't be doing that. So we want to find out how many miles she'll have driven if it took her 8 gallons. That's our goal. Well, what we need then is a function that we can plug 8 gallons into that will spit out a predicted number of miles driven. And that's exactly what we were developing in the last couple of sections, is this ability to find a regression model to represent given data sets. If we look at the data, we would be able to say reasonably like, oh, well, 8 is close to 8.1, so she drove somewhere close to 260 miles, maybe 250, a little bit less than 260, maybe 240, even, who knows. But probably somewhere in that range. But that's just a really rough approximation. We want to get a little bit more precise in our predictions, so we're going to generate our regression model first. So to do that, we're going to go to Excel, enter in our data, and look at the scatter plot. Here's our scatter plot. And I'll go ahead and we could do some things to make this scatter plot a little nicer, fix the axes, but we'll just go get the regression line. That's what we're interested in here. So I want to add the trend line. If I, again, go to more options, I could play around with the different options, but this one looks pretty clearly like it should be modeled by a linear function. So we'll leave it as a linear model, making sure we display the equation. And what we want for our problem really is just the equation. That's all we're really concerned about here. So let's go ahead and bring our equation over. If you want, you can copy the whole spreadsheet over, or the whole scatter plot over. It's not a bad idea. It's not required in this particular question. They didn't specifically ask for it, but it's always nice to have it there if you wanted to look at it. So there's our scatter plot for this given situation, but really what we're interested in is the equation of the regression line, which is right here, 32.365 times x minus 2.0764, okay? So we have y equals 32.365 x minus 2.076. And again, if we were being careful here, we should say, well, x is the number of gallons of gas. We should always label or describe or define our variables. If we write an equation, we should always say what the variables mean. And in this case, again, y is what we would expect the number of miles driven to be. So y would be the predicted number of miles driven. And now we have this equation that allows us to make predictions about how many miles we're going to drive based on the number of gallons of gas we use. So if Jen needs 8 gallons of gas the next time she fills the tank, how many miles will she have driven? Well, this was saying that x equals 8, right? So we can say y hat would be equal to 32.365 times the 8 gallons minus 2.076. And now we can go ahead and just type that into the calculator. So we pull up the calculator, 32.365 times 8 gallons minus 2.076 is going to equal 256.84, and it asked us for the predicted mileage to the nearest mile, so that's going to be 257 miles. Okay, and so this is the whole point of regression models. This is why we use them, is to develop an ability to make predictions about unknown values of the variables. Okay, now this process that we did is called interpolation. Again, the 8 gallons that we used is within the range of known values. Okay, so our range of known values goes again from 4.5-ish to 9-ish. So 8 falls well within our range of known values. So since we're looking at a value that's known, or excuse me, in the range of known values, this is called interpolation, because our regression model is well defined within the known values. In the next section, we'll talk about extrapolate, or the next part of this section, we'll talk about extrapolation, which is trying to make predictions for values out here. Okay. So let's go to part B here. It says, if Jen has driven 200 miles to the nearest tenth, how many gallons of gasoline can she expect to need? So here, what we're really doing is just changing things around. Now we're saying she actually did drive 200 miles, and you really could write this equation either way. You could say y equals 32.365 times x hat, and say, if I know y, I can predict x. Same basic concept applies here. So if I'm looking at Jen's situation, she has driven 200 miles, and we know that the regression model says 32.365 times x minus 2.076. And so now we're just solving for x, right? The question is how many gallons? So that would be finding x. Well, we know how to solve equations by doing inverse operations. So if I add 2.7076 to both sides, I get 202.076 equals 32.365x. And of course I can just divide by 32.365, and x will equal whatever 202.076 divided by 32.365 is. Okay, so we can pull out the calculator again and do that division real quick. And we get 6.24. Says to the nearest tenth, so we can just say 6.2. We would expect then that Jen used about 6.2 gallons of gas on her 200-mile trip. Okay, so these are both, again, examples of interpolation. She drove 200 miles. That's within our range of known values. So this is also interpolation. Okay. In the next video, we'll talk about extrapolation.